Okay, so we're back, and I'm going to try to finish this lesson. The second half, I'll try to make it a little bit shorter since I noticed that the first video ran a little bit longer than I expected it to. But what are we going to talk about here? So we're going to introduce radians. Radians are another way to measure angles besides degrees, and you could argue that they are a better way to measure angles. And I would argue that because what we're going to do is we're going to first say define a radian, and I wish I could had drawing tools on here, but we're going to define a radian as the angle that a single radius of the circle would make. So the radius of this unit circle, right, is 1. So if I took this radius and I stretched it out on the unit circle, on the circumference of the circle, question is how many radii could I fit around the circle, around the entire circumference? Another way to ask that question is what's the circumference of the circle? Now, hopefully you remember that there's a formula for the circumference of a circle, and the formula is that the circumference is 2 pi times the radius. So if the radius is 1, that means that if we measure the circumference of this circle, we actually would get 2 pi. You can check and you can watch it draw out 2 pi. So because we are measuring in kind of the units of the radius, we could say that there are 2 pi radians, 2 pi times the radius around the circle. And that's true for any circle. So this is why I would say that radians are a better way to measure angles, because if we were measuring in degrees, you could say that there's 360 degrees around this circle, but 360 is a very arbitrary number. Like who chose that, right? Versus in radians, we'll say that there's 2 pi radians around the circle, 2 pi of the radius. And the radius is kind of the definition of the circle, right? Every single point on the circle is that distance, that radius away from the center. So we're defining the circumference and we're defining angles now in terms of the defining feature of a circle, which is the radius. So anyway, long story short, there are 2 pi radians around the circle. Point A here in red is shown on the unit circle. What angle is this in radians? So you could try different things. Maybe test it out on your own if you feel like it. But here, I'll try a few different things. So we know 2 pi. And if you just type pi, it turns it into the pi symbol. 2 pi is all the way around the circle. That's how many radians are all the way around. So maybe a question for you. What would 1 pi or just pi be? Well, 1 pi is going halfway around. And yes, I know that there is another way to define this in terms of tau. I'm not going to get into that. Clara, if you want to use tau, go ahead. Though it won't work on these kind of like automatic things. Anyway, okay. So 1 pi is halfway around the circle. So what would the angle be for here? Well, it would be half of that. So one way you could write it would be 1/2 pi, and that's fine. The standard way you'll see this written is as pi divided by 2, pi over 2. And that is the same as a 90-degree angle. So think about this. The whole thing is 2 pi. There's 1 pi halfway around, This is pi over 2, half of that. I know this is kind of crazy because everything's going to be in terms of pi because 2 pi is going all the way around the circle. Probably. Here's a 45-degree angle. What's the measure of that in radians? Go ahead and think to yourself about that for a minute. Knowing that, all the way around is 2 pi, a 90-degree angle is pi divided by 2. What would a 45-degree angle be? If you think about it, well, it's half of that 90-degree angle, so it's half of pi over 2. It's actually pi over 4. That's a 45-degree angle. Another way to think about this is kind of just like, think about slicing up, a pie, a pizza pie, except that pi here represents half the circle. So a 45-degree angle, there's 4 of them in the half of the circle. It's a quarter of kind of like this half. So it's a quarter. It's pi over 4. It's a good way to remember this. Here's some practice. Try matching up these angles in degrees with the angle measure in radians. If you need to, go back and look at the unit circle, and you can plug things in here to see where they would fall. But also think about, just dividing up the unit circle into pieces. Like this is a quarter of the way all around to 180. Try this on your own. Go ahead, pause it. I'm not going to give you the answers. Try to do that on your own. Okay, so hopefully you tried this. So now notice if there's no degrees symbol, and especially if things are written in terms of pi, then you can assume that that is an angle measurement in radians. So for example, here's an angle measured in radians. It's 5 pi over 7, 5/7 of the way around to 180. I don't know what degree measure that is. I'm sure I could calculate it, but what do we know? We're going to go back to the sine and cosine of this angle. So what's the sine of this angle and what's the cosine of this angle? Remember, sine is the y-coordinate. So 0.78 is our sine of 5 pi over 7. And our cosine is the x-coordinate, so it is negative 0.62. Give an example of your own, of an angle in radians with a negative sine and a positive cosine value. So now I want you to think. We're going to write it in terms of radians, which means in terms of pi. Something with a negative sign means it's a negative y value, so it's down here in quadrant 3 or 4. And a positive cosine value means it's positive x, so it's down here in quadrant 4. So what kind of angle could you write in radians and get down here in quadrant 4? So it would be somewhere between close to 2 pi. Technically, this would be, here's pi, here's 2 pi, so this is like pi and a half. Or sometimes people will write it as 3 halves pi, like I write it this way, 3 pi over 2. That would be this angle right here. And we want something in the quadrant, so we need something bigger than that. Something bigger than 1.5, but smaller than 2. Could say maybe 1 3/4 pi, right? So like 1 pi would be here, and then 3/4 pi would be like this angle right here, 3/4 of the way to here. So how could you write that? You could write like 1, like I kind of want 1 3/4. So I want this 1 there. Like I kind of want this, right? 1 3/4 pi. And that would work. There's another way you could write this. If you, instead of as a mixed fraction, you could say, well, 1 3/4 is the same as 4 quarters and 3 more, so 7/4 pi is another way to write that. Here's an interesting one. An angle is shown, so it's pi over 3. What does that mean? What angle in degrees is that? State another angle in radians that has the same sign but the different cosine value. Okay, so this is tricky, right? We want the same sign, which is kind of like before. We want the same y value. We want a different cosine, so we want the reflected angle over here with the same y value but the negative of the x value. So in other words, we want kind of the angle that would make pi over 3 from this side. How do we do that? Well, we know that full going from 0 to 180, that's 0 to pi. And we want to take off a third of pi. This is what pi over 3 means, a third of that. So really we want 2/3, right? 2/3 pi. So how could we write that? We could do 2/3 pi, or sometimes people will write this as 2 pi over 3. It's just the same thing as 2/3 pi. And we end up at this angle, which is the reflected of that. And if you notice the sign, the y value is the same, cosine is negative, is the negative version. Okay, here's one I want you to try out on your own. I know, this is tricky, this is hard. State another angle in radians that has the same sign but a different cosine. So same thing, same sign but different cosine value. Can you find another angle that would match this one, 7/6? 7/6 pi, 7 pi over 6. Try it on your own. I might help you out with this one after. Okay, so hopefully you tried this. This one is tricky. We want the same sign, so we want the same y value, which is negative here, but a different cosine. So we want the reflection over here, right? Now what angle is this? 7/6 pi. That means it's 6/6, or 1 whole pi, right? Just going from 0 to 180. And another sixth. So this angle from here is actually it's an extra pi over 6. So there's two ways to do it. Actually, the easier one would just do would be to make a negative angle. To say negative, we want to go down pi over 6. And that would actually get you to the right place. Or if you don't want a negative angle, you could ask, well, how do I get to what's the positive version of that? Well, remember this is 2 pi going all the way around. 2 pi, and then we're kind of like subtracting pi over 6 from that. So what is that? Well, 2 pi, 2 full pi is the same as 12 pi over 6. That's the same as 2 pi because 12 divided by 6 reduces to 2. And we're taking off 1/6 of it. So really, 11/6 pi also work. Okay, so that is the end of this lesson, of the main part of this lesson. There are a few more screens I want you to try to answer going forward. I'm not going to help you out with them, but I want you to kind of investigate and try them on your own. How many did I put in here? I gotta fix this, relabel it. I think there's 3 challenge questions. And then, a little explanation challenge question. So 3 challenge questions. Try them on your own. Let me know how this lesson went. At the end, I think I put a reflection in here. Yeah, just let me know what questions you still have, what was confusing, what made sense, how you're doing. I hope you have a wonderful week. Stay in touch. and please ask questions. All right. Bye, guys. Have a wonderful week.